So we are asked to find the equation of a quadratic given 2 points, one being the vertex and the second being the point it has to cross through. So once we are given the vertex, we can automatically go ahead and use the quadratic equation y is equal to a times x minus h squared plus k. Since we have the vertex and we know that the vertex has coordinates h or 4 comma 9, but it's mainly written as h comma k. And here in this example, we're given that h is equal to 4 and k is equal to 9. So now we can go ahead and write our equation. Y is equal to a times x minus 4 squared plus 9. And we want to go ahead and plug in our point so that we get 3 is equal to a times 2 minus 4, which is negative 2, squared plus 9. And what we want to do now is go ahead and subtract 9 from both sides, so we could get negative 6 is equal to a times 4. And we can go ahead and divide it by 4, giving us a is equal to negative 6 divided by 4, which we could reduce to negative 3 over 2. And basically, we have to go ahead and plug in a so we get our full equation, which is going to be y is equal to negative 3 divided by 2 times x minus 4 squared plus 9. And we can go ahead and verify our point. So let's go ahead and do that. So we're going to have y is equal to negative 3 over 2, comma 2 minus 4, which is negative 2, which is we know it's 4, plus 9. We're going to have y is equal to negative 12 divided by 2, which is the same thing as negative 6, plus 9, which gives us y is equal to positive 3, which is indeed our solution. So now that we have this example covered, we're going to go ahead and look at another case where we are only given 2 points, and we will see how to go ahead and find the equation only given 2 points. Then after that, we'll go ahead and look at an example with 3 different points. So let's go ahead and look at the other example. So in this example, we are told that we have a quadratic that has to pass through the point 4, 5 and 2, 7. And this is a special case since the equation we're going to be using is y is equal to ax squared plus bx plus c. And here we see that we only have 2 points, meaning we're going to have to find 2 variables. So when we have only 2 points, we're going to have this quadratic y is equal to ax squared plus bx. Since we can't have c because we would need to find 3 different variables, but we're going to go ahead and find the equation for this quadratic by plugging in our points. So we're going to get 5 is equal to a times 4 squared, which is 16a plus 4b. And our second equation is going to be 7 is equal to 4a plus 2b. And we can go ahead and use one of the methods that we learned, which is, well, we're going to use elimination since it's much more quicker. We're going to multiply by -2, which is going to give us 5 is equal to 16a plus 4b. And then -14 is equal to -8a minus 4b. And we're just going to go ahead and add from top to bottom. So we get -14 plus 5, which is -9. And 16 minus 8 is just 8a. And 4 minus 4 is 0. So we just got to go ahead and find what a is. And we get a is equal to -9 over 8. And we want to go ahead and find b now. So we're going to go ahead and multiply the equation by 4 or -4. So we could get 5 is equal to 16a plus 4b. And then we're going to have -28 is equal to -16a minus 8b. And now we're going to go ahead and just add from top to bottom, giving us -23 is equal to 0a minus 4b, giving us b is equal to 23 divided by 4. And we want to go ahead and verify that it crosses through one of these points. And to do so, we're going to use our equation that we have now, which is y is equal to -9 over 8x squared plus 23 divided by 4x, which we can just factor out to be x times -9 over 8 plus, or -9 over 8x plus 23 over 4. So we're going to go ahead and plug in 2. So we're going to go ahead and get 2 times -9 over 8 times 2 is going to be -9 over 4 plus 23 over 4. We're going to get 2 times 14 over 4, where we can go ahead and multiply 2 now to get 14 divided by 2, giving us 7, meaning that it does cross through our point. And we can go ahead and use the next point and verify it, but since we have already one point, we could already go ahead and say that that our equation is true. But we want to go ahead and just plug in 4, 5 to see if it does satisfy our 2 points. So we already have 7 and 2, or 2, 7. And now we're going to go ahead and plug in 4. So we have 4 times -9 over 2 plus 23 divided by 4. And we're going to multiply -9 over 2 by 2. So we have 4 times -18 over 4 plus 23 over 4. And that is going to give us 4 times 5 over 4, which if we multiply 5 times 5 over 4 is going to give us 5, because 20 over 4 is 5. So we now have that our quadratic does indeed pass through these 2 points. And we're going to go ahead and look at one more, but this time with all 3 variables included, such as a, b, and c. And we're going to solve a system of equations with three variables. So let's go ahead and look at that example next. So here we have a quadratic, and we have to find the equation given 3 points now. So this is going to be our final example. And here we basically could tell that we're going to have to use the full quadratic now, which is y is equal to ax squared plus bx plus c, because we're going to have to plug in three different coordinates, giving us three different equations to solve for a, b, and c. So we're going to go ahead and plug in the first one, which is 1 comma 3. So we have 3 is equal to a plus b plus c, because x is 1, so it's not going to change anything. And we're also going to have the second equation where we have y is equal to 1 and x is 2, so we have 4a plus 2b plus c. And we also have -3 is equal to 36a plus 6b plus c. So we're going to go ahead and use the elimination method by including all three of our equations. So first we want to take our first equation and pair it up with the second equation, giving us 3a plus, or no, not 3a. 3 is equal to a plus b plus c. And we want to get rid of c, so we have to go ahead and multiply the whole equation from the top by negative, and this will give us -2 is equal to 3a plus b, and c is equal to 0. And now we want to go ahead and plug in or use equation 2 and 3, which will give us 1 is equal to 4a plus 2b plus c, and -3 is equal to 36a plus 6b plus c. We're just going to multiply the top one again by negative, and we're going to get -4 is equal to 32a plus 4b. And now we're going to use our equations that we have here, or our answers, and we're going to put them together so that we get this new system of equation, which is 2, or -2 is equal to 3a plus b, and -4 is equal to 32a plus 4b. So now what we want to go ahead and do, oh wait, the first equation is, okay, yeah. So we're going to go ahead and solve with the elimination method again, since we could easily see that there's a b being 1. So we're going to multiply the whole top equation by -4, which is going to give us -8 is equal to -12a minus 4b, and -4 is equal to 32a plus 4b, which is going to give us 0b and positive 20a, and it is equal to, well, that's positive because negative and negative cancel out. We're going to have 4, and we are going to get that A is equal to 1/5. And we want to go ahead and plug in A into any equation to get B. So we're going to go ahead and plug in A into our second equation. So we have -2 is equal to 3 over 5 over 5 plus B. And we're going to go ahead and subtract 3 over 5 where we get -3 over 5 minus 2 is equal to B. And solving for B, we get that B is equal to -13 over 5. And now to get C, we're going to plug in A and B into whichever of the 3 equations we want. And we can find C, but since we see that our first equation is 3 is equal to A plus B plus C, everything is 1, we are going to go ahead and directly plug AB into our first equation, giving us 3 is equal to 1 over 5 minus 13 over 5, and we're going to find C. So here we have 3 is equal to -12 over 5 plus C, and we have positive 12 over 5 plus 3 because we moved -12 to the left-hand side is equal to C. And here we're going to get 27 over 5 is equal to C because 3 is the same thing as 15 over 5, and 15 plus 12 is 27. So now we have that our quadratic equation is y is equal to 1 over 5 x squared minus 13 over 5x plus 27 over 5, giving us that this equation where we can go ahead and multiply everything by 5, whereas we will go ahead and get 5y is equal to 1x squared minus 13x plus 27. So we're going to go ahead and plug in 1 because that is going to give us 3. And we want to go ahead and see which of the points are correct. So we're going to go ahead and plug in 1 first, which will give us our first answer. So we have y is equal to 1 over 5x squared minus 13 over 5x plus 27 over 5. So we're just going to leave it like this. And we're going to just plug in x is equal to 1. So we get y is equal to -12 plus 27 over 5, which is the same thing as 15 over 5, which is indeed 3. So we basically get 1 comma 3 is correct. And we're going to go ahead and plug in our second point, which is 2 comma 1. So plugging in 2 for x, we get 1 over 5 times 4, which is going to tell us we have 4 over 5 minus 26 over 5 plus 27 over 5, giving us 4 plus 1 over 5 is equal to 1. And we have our final point, which is going to be 6 comma -3. now we're going to go ahead and see if that point does indeed satisfy our equation. And we're going to have y is equal to 36 over 5 minus 78 divided by 5 plus 27 over 5. And 36 plus 27 is going to be 50. 63 minus 78 which is going to give us negative 15 over 5, which is negative 3. So our equation does satisfy all three of those points. And we were able to solve or find the equation using a system of equations with three variables. And we could have used other methods like Kramer's rule or Gaussian elimination or substitution, but since elimination is the easiest and fastest one, we were able to find the answer pretty quickly rather than having to take our time and finding values by doing substitutions or finding matrices. But we were able to solve it rather quickly with just the elimination method. So thank you for watching, and I hope you have a good day.